If a CPU has a 16-bit address bus and 8-bit words, how much memory can it address? I'm studying for an end-of-semester exam and am confused with the following question. If a CPU has a 16-bit address bus and 8-bit words, how much memory in KBs can it address? My understanding would tell me that it can address 64 kilobits. However, to do this I just used 216 equals 65,536. That calculation never actually took into account 8-bit words, so I am not sure if it is correct. Also, what does 8-bit words mean? Cheers!
A word, in the majority architectures, is the largest piece of data that can be transferred to and from the working memory in a single operation. The largest possible address size, used to designate a location in memory, is typically called a hardware word. So, your CPU will be able to address 64 kilobits, 2 to the power of 16, but will only be able to transfer in a single operation 8 bits.
A machine word, or commonly just word, is the largest unit of data that the CPU can manipulate as a whole using common instructions. This has nothing to do with memory addressing. What matters is the unit of address resolution, which is commonly an 8-bit byte even on 16/32/64-bit architectures. It doesn't have to be equal to the machine word size, but it probably is in your case. An 8-bit addressable unit combined with 16-bit address bus amounts to 64 KB of RAM that the CPU can address.
Also, what does 8-bit words mean? In context, the word size goes with the address size to describe the memory bus. There are 16 bits going out to the memory, so it can choose 64 key locations. Then, each location contains 8 bits. The word size here may or may not match the CPU computation unit size, and this may or may not match the logical granularity in addressing. For example, a CPU may advertise a 16-bit bus. For this purpose, it uses 16-bit addresses in its instructions, and like your example has 64 key. But it has 15 bits of address bus and 16 bits of data bus. It only needs 32 key addresses and always gets 2 bytes with each location. If an instruction wanted 1 byte, it would dispatch the address with the least bit missing, fetch both bytes in that step, then look at the least bit of the desired address to decide which half to use. Note that bank switching, PI, etc. mentioned by others are not relevant here. A memory management unit might use 16-bit addresses and have 20-bit hardware address, so the CPU needs to switch and map things to make use of the actual 20-bit address range of RAM chips that can be addressed. Be sure to specify units in your answers. 64 key. Of what? 8-bit words, making it, still, 64 key bytes of addressable RAM. That step eliminates confusion and makes problems like this trivial.
There are 2 sides to this, what your instructor probably wants you to tell him, and what the reality is. First, what your instructor probably wants you to tell him. 16 bits can address 2 to the power of 16 memory locations. Each location is 8 bits. So we can address a 524,288-bit, 65,536 octet memory. This, however, reflects a rather oversimplified worldview. The reality is more complicated, and to give a definitive answer requires more information. Some of the ways in which real systems can be more complicated than this include: many processors do not have a dedicated I/O map, so parts of the memory address space may need to be used for things other than memory. The word size of the processor is not necessarily the same as the width of the memory data bus, or the smallest addressable unit of memory. Some buses allow the movement of varying size data units. This requires further addressing which may or may not be handled by bits of the main address bus. Some buses multiplex different signals on the same lines. For example, SD-RAM uses the same address lines twice to send a row address and a column address. Many systems used bank switching approaches to allow programs to access more memory than the processor could natively address.
Según la filosofía, es posible usar